Math 206, now that we are comfortable with two-dimensional measurements, let's develop the area for the formula for area of a rectangle, parallelogram, triangle, and kite and trapezoid. So first, rectangle should be really familiar because we've used this method to even talk about multiplication. So if you have a rectangle that has width, say 3 units long, and length, say 4 units long, to find how many square units is inside the rectangle, you'll multiply 3 times 4 equals 12 square units. So the area of a rectangle is always going to be the length times the width. So that one we should be really familiar with. Now, what about a parallelogram? So for a parallelogram, here's what you want to imagine doing. You chop off one triangle from the side of your parallelogram by drawing in the altitude. Now you have a 90-degree angle here. And now you take this triangle and you move it over to the other side. And when you do that, what you end up with is a rectangle. And the area of this rectangle will be the area of the base here. I just took this section here and moved it over here. So this side length here is the base, and so that's like the length of the rectangle, and the width of the rectangle is exactly what the height is, which is the length of the altitude here. So then the area of the rectangle would be the base times the height, where base is the side length of one of the sides. It could be the side AB here or the side AD here. And then the height is the length of the altitude dropping down from a vertex down to whatever you called the base. So if you called this the base here, AB, then the height would be dropping down from vertex D. So that would be the height. But if you called AD the base, then your height would be this length G here. So again, you could have either gotten the area by doing B times H, or if you called this the base of your parallelogram, it would be A times G. And it should make sense. Again, we're just kind of like chopping this triangle off of the parallelogram and moving it over there. All right, let's now consider the area of a triangle. And we've seen this before. Usually when you have a right triangle, you imagine that triangle as being exactly half of a rectangle, right? So the area of the rectangle is the base here, which usually you'd call like the length, times the height here, which normally you would call the width. So the area of this triangle would be exactly half of the base times the height. Now we can see exactly that formula if you have a triangle that's not a right triangle. First, what you need to do is decide on which side length you're going to call the base, and then draw in the altitude. So drop a perpendicular segment down from the opposite vertex. And now you have a base and the height. Now imagine that you take this triangle, make a copy of it, and flip it over. So now you have 2 copies of that same triangle. The quadrilateral that you have here now is a parallelogram. And we just saw a second ago that the area of a parallelogram is exactly the base times the height. So the area of this triangle will be exactly half of that. So it's always going to be 1/2 base times height. And again, it doesn't matter which side you use to be the base of the triangle, but then the height has to be the altitude down from the opposite vertex. Okay, so let's do a few examples where we calculate areas. Right, here's a parallelogram. And they don't give me the altitude that I'd like for them to give me. I'd like them to give me this height here so I could do 10 times whatever this is, but I don't have that. Instead, they give me this altitude. So I need to use the opposite side as the base, BA. So this side is the same as that side, that's 5 centimeters. So the area here will be base times height. My base is 5 centimeters, and the height here is the altitude that they gave me, 8 centimeters. And then when you do 5 times 8, then our units will be square centimeters, 40 square centimeters. Again, this one always kind of looks confusing to students because the altitude, right, it intersects not the base, but the extension of the base by a line here. So it just kind of looks awkward, but it's the same process. Find the, if you have the altitude, find the length of the base that's opposite that vertex there, the base that intersects that altitude, 40 square centimeters. Let's do this one. Here I've got a triangle. The area should be half of the base times the height. Here, my base is 10 centimeters and my height is 4 centimeters. So half of 10 times 4, that'll be 20, and my units are square centimeters. Again, you can even think about with units, this is 10 centimeters times 4 centimeters. Centimeters times centimeters is centimeters squared. So you never really have to guess at what your units are if you use them in your calculations. All right, one more. Here's a triangle. I know that the area should be half of the base times the height. So again, this is one of those problems like visually it'd be nice if they gave me this length for the base and this altitude for the height, but they don't. Instead, they give me the length of this altitude, which is 4 centimeters. And where is the base that corresponds to this altitude? It's right here. So again, the altitude kind of intersects the extension of the base, which is kind of a pain visually. But either way, the base now is 2 centimeters and the height is 4 centimeters. So I've got 1/2 times 2 centimeters times 4 centimeters. So that gives me 4 square centimeters for the area of that triangle. Let's look at some areas of formulas for areas of other shapes. This is one of my favorites, the area of a kite. So we'll start by noticing that one of the diagonals is a line of symmetry for the kite. So this diagonal, the length of which is D1, we'll say, chop your kite in half and then reposition this lower triangle up top here and this lower triangle up top here. And what you end up with is a rectangle. And what are the dimensions of this rectangle? The length is the length of the first diagonal, and the height is exactly half of the other diagonal. So the area for a kite will be, you can either write it as D1 times D2 over 2, or I think a little bit easier, make it half of the first diagonal times the second diagonal. All right, now for a trapezoid, we're going to do the same thing where we kind of chop up the trapezoid and find the area that way. So if you have a trapezoid and the information that you're given is the length of one of the bases and the length of the other base. Usually we'll call these B1 and B2. And remember that those two lines or those two line segments are parallel to each other, right? And the other piece of information that we're given is the height. So to calculate the area, what we'll do is imagine cutting the trapezoid into two triangles. This triangle here and this triangle below. Okay, so notice The base of this triangle here is B1, and the height is H. And the upper triangle here has base B2, and its height is the same as H. So the area for the trapezoid will be the sum of those two triangles. So the area will be, first the blue triangle, 1/2 B1 times H, plus the area of the pink triangle, 1/2 B2 times H. So this works as the formula for the area of a trapezoid, or you can sort of factor out those common factors like 1/2 and H and write it as 1/2 times H times what's left. What's left from this term is B1, and what's left from this term is B2. So there's the formula for the area of a trapezoid. I think that one's pretty fun. Let's go ahead and see that in practice. Here I have trapezoid. Base 1 is 16 centimeters, base 2 is 12 centimeters, and the height is 4 centimeters. So the area here will be 1/2 times the height times B1 plus B2, which gives me 2 times, what is this, 28, which is 56. 56, and I forgot to write my units. Square centimeters. All right, let's do another one. Here I can use the formula for the area of a trapezoid, or because I have so much symmetry, let me go ahead and just chop this into some pieces. If this is 8 centimeters, this is 2 centimeters here, and since I've got a 45-degree angle here, I know that this is an isosceles trapezoid. So this triangle here and this triangle are exactly the same. So let me go ahead and chop this triangle off, and I will add it over here. So now what I have is a rectangle. And again, since this is here, this is a 45-degree angle, 45, 90, this has to be a 45-degree angle. So now this is an isosceles triangle right here. So if I know that this has length 2 centimeters and it's 8 altogether, that means that this side length here must be 3 centimeters, and this one here must be 3 centimeters as well. And since this is an isosceles triangle, the height here is 3 centimeters because the two legs of the isosceles triangle must have the same length. All right, so now I have this pink rectangle after chopping off this triangle and putting it over here. Let me just calculate the area of that triangle. The area of that rectangle. It'll be the length, which is 3 centimeters plus 2 more centimeters, or 5 centimeters, times the width or the height here, which I've calculated to be 3 centimeters. So the area is 15 square centimeters. I did do a little bit of work to figure that one out.